This one is a cross-sectional volume problem. I think I'm going to try and do all A, B, C, and D in this video. So I'm going perpendicular to the x-axis. So, by the way, you should be able to get to this graph on your own. So I'm going perpendicular to the x-axis, which is going to be a bunch of slices like this. That means I'm going dx. I will highlight one slice. I'm going to do, I want to find, remember I like to call it B for base of the shape that we're going to build up coming out of this thing. So I'm going to let B equal top minus bottom, since I'm going vertically here. The top is this equation, which is what they gave us, y equals root x minus 2. And the bottom is 0. So we get root x minus 2 minus 0, which is just root x minus 2. And I'm going to use that for each of these different integrals that I need to deal with. So part A wants me to do squares. So, I didn't label this on the thing. This should be marked as 2. So I am going dx for all of these. So for the squares, I'm going to go integral of base squared dx. I'm not going to go over where all of these formulas come from. You should be good with them based on some of the stuff that we've done in class. You should be able to work some of them out. But really, it's always just, a different coefficient out here. So I've got 1/2 b squared dx. Remember, this is my b right here, which gives me, or sorry, not 1/2, just have b squared. It would be 1/2 if it was the isosceles right triangles. So that's b. So I get integral, maybe I'll write b squared is going to be x minus 2, because I square the square root out. So integral of b squared is going to give me x minus 2 in here, going dx, and we're going to go from this spot to this spot. So I go from 2 to 6. Next one is rectangles of height 3. Well, that's going to give me integral, and I can put my 3 out front times the base, right? So it's not b squared in this case, so I get, times the base dx. So I go integral, same numbers, 2 to 6, put my 3 out front. My b is then the root 1, root x minus 2 dx, like that. Part C is equilateral triangles. So you should know that the coefficient for the equilateral triangles is root 3 over 4. And then I do integral of b squared dx, which gives me, root 3 over 4 integral. I'm going to go from 2 to 6 again, and the b squared is x minus 2, so I get x minus 2 dx, like that. Last one, part D, is semicircles. So that gives me pi over 8 times the integral of b squared dx. So I just get the same thing as I got on the previous one, but with a different coefficient. So I get pi over 8 integral 2 to 6 of the x minus 2 dx. Now, if you need some help figuring out where those different formulas come from, so for example, this, well, we talked about it in class. I don't currently have a video up on that stuff. Maybe at some point I'll put one up. But really the key for figuring that stuff out, where those formulas come from, is going back to your notes.